Good afternoon, everyone. My name is Qingzhi Liu. I'm going to make a presentation about the Internet of Things in agriculture. So first of all, let me introduce myself a little bit. I did my PhD in Delft University of Technology. During that period, my main research was about Internet of Things. After that, I went to the Eindhoven University of Technology. I did 3 years postdoc researcher. My research was about using AI in resource-constrained Internet of Things. Now I'm the lecturer of Information Technology Group of Wageningen University and research. My part of my work is to use Internet of Things and artificial intelligence in agriculture. In today's presentation, I'm going to discuss Internet of Things based on three parts. In the first part, I'm going to introduce you some basic knowledge about Internet of Things. After that, I'm going to focus on two key topics of Internet of Things, including communication and computing. I will use some new technologies such as wireless mesh network and AI IoT to explain how to design such system. So first of all, let's take a look at the architecture of a typical IoT system. So generally, you can consider a IoT system with 4 layers. On the bottom layer, it is called a raw data layer. It is used for collecting some data. For example, you deploy some sensors. You want to measure what is the temperature or humidity, these kind of things. On top of that, it is the network layer. I guess some of you have already heard these protocols, for example, Wi-Fi, Bluetooth Mesh, or Zigbee. These protocols, communication protocols, they are used to connect all these sensors, all the devices together and aggregate the data to a destination. After that, that is the processing layer. The processing layer is for saving data and doing some data processing. The top layer is about application. We want to use the data to provide some services, for example, localization, or we want to monitor the health of some people, or we want to control the traffic. So this is the architecture of a IoT system. Then maybe you would ask, okay, what can IoT be used for? Nowadays, IoT system is widely used in almost every area of our daily life. It's everywhere. For example, it can be used for transportation, logistics, agriculture, and healthcare. In this workshop, we want to focus more on agriculture. In this field, the IoT can be used for example, estimate what is the weather, what is the condition of the environment, or give some diagnosis to the health of some animals, or optimize the usage of a pesticide. These are the applications of an IoT system. If we zoom into the application of IoT system, let's focus on the agriculture. How to deploy such an IoT system into a farm. Here, I draw a simple graph to show what kind of application we can use. So for example, here, we can use a camera to monitor the activity of some animals. We can also deploy some sensors to measure the condition of some plants. At the same time, we also need to make some flow control to properly collect useful information to the server, for example. Or we also want to make the sensor make the sensor stronger. For example, we not only want these sensors to send the data, but also doing some data processing work. Here is another example. Because on the farm, there are some vehicles and some machines. They need to coordinate with each other to finish one task. So these are the applications, a typical deployment of an IoT system in a farm area. But now here is the question, how to implement this? This is just a plan, how to implement that. There are many challenges. To deploy an IoT system, we need to cope with, for example, the load balancing of communication. We need to balance the workload for different servers. We also need to standardize the data structure because the data comes from different devices. We need to know, okay, well, what does this data, what's the meaning of this data? We also need to provide some kind of a quality of service for the clients. So these are the challenges. But are all these challenges important for agriculture? That's an important question. What's the most important point for agriculture? So from my viewpoint, for agriculture application, some of these challenges are not that important. For example, quality of service. For kind of application of IoT, this is important. For example, we say to monitor the health of some patient. If there's a delay in transmitting some data, even if it's just 1 second, that is already a big problem. But for some agriculture application, this is not that important. From my viewpoint, the most important points for agriculture are low cost and easy maintenance. In my mind, so if we want to sell IoT system to a farm, I guess the farmer, the first question from the farmer is that, okay, what's the price? Is it easy to use? So these are important because they want to, we need to deploy this IoT system in large scale, and it is not easy to maintain. So how to cope with these two challenges? In the next few slides, I'm going to use two techniques. It's called wireless mesh network and IoT to cope with these problems. Okay, first of all, let's take a look at this wireless mesh network and agriculture. To understand how to use wireless mesh network, the first step is to take a look at the typical network architecture of Internet of Things. This is a typical architecture on the left side. There are some source nodes. They are used for collecting or producing some data. For example, they are the sensors. And all these data are collected to a sync node. And then further, these data are further sent to a storage, a database, and some big data platform. And finally, there could be some applications. These applications provide some services based on the collected data. So if we summarize this structure, this network structure of IoT system, there are two steps. The first step is to collect data. The sync nodes collect data from end devices, such as sensors. After that, the data is processed on some platforms, on server, on cloud, all possible. Here's an example. For example, we say, okay, we want to monitor the health of some people. Every people, we attach some sensors, and these sensors send data to the smartphone, and the smartphone send data to the server, and doctors or the users check and analyze these data from the server. This is a classic or standard network architecture of Internet of Things. Now the question is that, can this hierarchical Internet of Things, this structure, cope with complicated large-scale problems in agriculture? This is what we want to know. The answer from me is no. If we use this standard IoT agriculture, especially that hierarchical agriculture structure, we cannot solve the problem. Why? Because it's too complicated. So, for example, let's say this is more complicated hierarchical IoT infrastructure. In this system, there are many types of data. Audio data, video data, text, sensing data, and some of the devices are mobile. All these data are collected to some devices, to some servers, because these data are different, the network are different. We also need different types of system to aggregate data finally to the server, to the cloud. And finally, we also need to sacrifice different user, satisfy the requirements from different users. So how to cope with this complexity? One possible solution is a wireless mesh network. What is a wireless mesh network? Here is an example. In this wireless mesh network, every device can communicate with the neighbors. For example, this is a device, and this is the transmission range. It can talk with the neighbor devices. And another important point is that every device helps the others to forward messages. So for example, let's say if this device wants to send a message to this one, to top one, then it will first send a message to this laptop, then maybe to this sensor, then to this another laptop, and finally arrive to this smartphone. So they use a multi-hop communication method to transfer data between machines. So if we take a look at this network, there are two key advantages. The first one is low cost, because in this network, we don't need to deploy a specific server or router or switch. Every device can communicate with each other. Every device help each other to route information, to route messages. And it is very robust. Even if you remove some devices from the network, or suddenly there are some new devices join into the network, still this network can operate properly. This is why it has low cost advantage. The second point is that it is very easy to maintain, because every device here, they only need to talk to the neighbors. They don't need to send the information far away to, for example, to a base station. So the power consumption in every device is compared with a hierarchical structure is low. So if we deploy many these kind of devices in a large area, we don't need to change the batteries of these devices frequently. So for example, we just need to change the battery once per year. That will largely decrease the simplify the maintenance. This is a wireless mesh network. So how to use this concept or this technique into applications? Here I can give you two examples, and I will also explain how we use these solutions for agriculture. The first one is using a wireless mesh network for remote control. This is a cooperation project with Signify. In this project, what we do is to deploy many devices in the building, and these devices self-organized into a mesh network. And we use these devices to control the lighting, to control send some signals between each other. So the key property is that these devices, that we do not need to purposely deploy some routers. They can organize by themselves into a network. In our experiment, we also purposely remove some devices and add some new devices. Still, the network is strong enough to transfer the data. Okay, this is the first example system. Then what we think is that we not only want to take advantage of the self-organization, self-adaptive property of a wireless mesh network, but also we want to take advantage of the low power consumption property of a wireless mesh network. So we built this project. It is a battery-free device. We deployed many devices in the building, and these devices harvest the energy from the radio frequency, and these radio are sent from the nearby wireless charger. So every device is battery-free. And in this system, all these nodes can give services to the nearby mobile devices. The services include sending some messages, for example, the temperature, and sending some localization information. And this system is already successfully deployed in the building. What we are working now is to merge these two systems together. This one is a typical wireless mesh network. It is very robust. It transmits data between each other, and this one is a low-cost, low power consumption network. So we are merging them together. We are thinking, okay, whether we can scale up this network into a farm area because of the limited devices. So in our experiment here, we only use deploy everything in the building. So now what we are doing now is to use a large scale network with a Hello Wi-Fi network to collect some data in the farm area. The final goal is to reduce the cost and simplify the maintenance of the system. This is what we are working on using wireless mesh network for agriculture. Okay, this is the wireless mesh network in agriculture. Now, I'm going to say something about AI, IoT, and agriculture. So first of all, what is artificial intelligence and IoT? The aim of AI, IoT is to merge these two concepts, these two techniques together. There are many traditional ways to do this. The traditional way is very straightforward. We first use some wireless sensor nodes to collect data. Or for example, we use surveillance cameras to capture the images and then send these images back to the server. And use the processing power of the server and machine learning models to detect, estimate, okay, what's the content in this image. That's a traditional way. In this traditional approach, it separates the data collection and data processing. The sensors, the network, the IoT network is only responsible for collecting data, and the server is only responsible for processing. That's the traditional way. But now the trend is different. We want to put, we not only want AI happens on the server, but also on the IoT devices, on some resource-constrained IoT devices. The key requirement in this trend is that AI IoT, this technique allows real-time operation without requesting centralized processing. Simply speaking, it is every device do not need to send, for example, image to the server to make some detection. Every device can do this image processing, image recognition by itself. That's the purpose. If we have this system, the benefit is also very clear. Low cost and easy maintenance, because we don't need to use a very large server to process all the data, so the cost is low. And because there is no server, no large server to, we don't need to deploy many models to recognize different data. So the complexity on the server will also decrease. It is also easy maintenance. Okay, so if we want to use AI IoT, first thing we need to is that we need to understand what is the structure of this kind of system, how to merge AI to edge IoT devices. This graph shows a typical edge computing structure. In my mind, there are 2 points that is very important in this structure. The first one is that we need to avoid transferring unnecessary data to the server. Traditional way, for example, these green blocks, they are sensors. Traditional way requires these devices send all the data to the cloud server. But here we need to avoid this, because this will increase the workload, the communication load of the server and the communication network. It's unnecessary. If this IoT device has some power to process the data, then process the data by the IoT device. That's the first point. The second point is that there are some possibilities that even if we want the IoT devices to process some data, because of the limited memory, limited processing ability, these IoT devices cannot do some large scale machine learning based data processing. Then we need to add some edge servers. These edge servers should be close to the IoT devices, and these edge servers are very cheap compared with the cloud server. These are the 2 important points in edge computing. So if we have this structure, how to use this in applications? Here is a typical structure for example application. Let's say we want to use this edge AI, or you call it AI IoT, to monitor the activity of some animals. So what we can do is to use the cameras to capture the image of these animals, and then send the data to some small devices, edge devices, or some IoT devices. Instead of directly send this data to the server, what we are doing now in edge AI is to make some pre-processing on these devices. So for example, in this application, we want to do some data analysis on some specific animals, for example, tiger. What we can do on the edge device is that we first make some easy recognition, whether this is an animal with 4 legs, for example, or it is a bird. This pre-processing is very easy. It's because it only recognizes some general features of the animal. So the machine learning model could be very small. It can be used in these small devices. After that, if, for example, we say, okay, this is an animal with 4 legs, then we know that, okay, this is maybe a useful data, and send the data back to the server to make further analysis. If using this edge device, we detect the object is a bird or some other unrelated things, then we remove or delete this image. That's the working procedure of this AI IoT system. We have already successfully used this AI IoT method into multiple agriculture projects. The first one is using multiple devices, many IoT devices, to recognize the activity of, in our experiment, we recognize the activity of people. Compared with the normal solution, we do not insert a large machine learning model in one device. So here, what we do is that we separate a machine learning model into parallel pieces and put these pieces into multiple IoT devices. And these devices coordinate and cooperate with each other to finalize the image recognition work. We have already deployed the system using the infrared camera and the depth camera. Now, what we are doing now is to extend this system from laboratory to a farm area. We want to deploy some cheap devices to capture the image and recognize the activity of animals. This is what we are working now. At the same time, we understand that using these devices to recognize the activity of animals is not enough, because in our system, in this system, all the devices are static. We are thinking, okay, what if we want to deploy some sensors on animals? Then these devices becomes mobile. How to organize these devices into a network and say, okay, these devices should cooperate to do some processing, and these devices should cooperate to do something. If all the devices are static, that's fine. But if they are mobile, that's a big challenge. So we found this deep reinforcement learning solution to cope with this problem.
Yeah, can you take care about time? It's almost.
Yes. I will finish in like 3 minutes.
Yeah, thank you.
Yes. I guess you know this deep reinforcement learning because there's a very famous application. It's called AlphaGo. It's from DeepMind. It is used for design application to play chess with people. The key point of deep reinforcement learning is here. We ask the agent to do some action for the environment. At the same time, observe the state and reward from the environment. So what we do is something like this. We use a DRL to organize the cluster of Internet of Things. Even if there are some dynamic objects in this network, we still can balance the size and workload of different clusters. How this can be used in agriculture? So this is what we are working on. We want to monitor the activity and the health of chickens. We want to deploy some sensors on these chickens and make some monitoring. Traditional way is very clear. We just attach a big sensor on the chicken and send all the data to the server. But we don't want to do that. We want to use AI in IoT devices. We want these devices from this chicken to process the data. So we need this method. Even if we deploy some sensor on the chicken, even if all the chickens are moving around, we're still using this method to find the cluster. So this, for example, these chickens, the devices on these chickens should cooperate to make some data analysis. That's the work we are working on. Okay, in summary, in this presentation, we discussed about the key topics of IoT system, including communication and computing. Wireless mesh network is a good way to reduce the cost and simplify the maintenance of communication network. The last one is the most important one, is that if compared with traditional AI solutions, AI IoT has higher benefits for agriculture. Yes, thank you very much.